All right, so now we're working on question 2 of exam prep, and we're given this x86 potpourri. So just as a reminder, we're given all the x86 calling convention here, and now we'll start answering some true or false. So in a normal non-malicious program, the EBP is always greater than or equal to the ESP. So that's true because the EBP is the top of the stack frame and the ESP is the bottom of the stack frame. Therefore, the top will always have a greater address than the bottom. Now, arguments are pushed onto the stack in the same order as they are listed in the function signature. No, that's false. It's in reverse order. And that's just as how calling convention states it to be. It's just a fact you have to accept. Next, a function always knows ahead of time how much stack space it needs to allocate. So this is true. This is done when the function gets compiled, and that is also something we just need to know. Next, step 10, restore the old EIP. RIP is often done via the ret instruction. So this is also true. The ret instruction is also equivalent to pop EIP, which is given here. So those two, pop EIP and ret, are equivalent, which is good to know. It might come in handy later on for project 1 in question 8. All right, next we're given some GDB output, and for those of y'all who have not seen GDB yet, because you haven't started project 1 necessarily, this type of command here allows you to basically print out addresses and values. So we're given two things here, and we're asked true or false. Is 62A the address of R, and is 70C the value stored at R? And so that's true. So whenever you're given GDB, the thing before the colon is going to be the address, and the thing after is going to be the value. Cool. So now we're asked about a bunch of different segments in calling convention. So I'm going to go up here to draw things out a bit easier. So we're asked what is part of the caller, what parts of calling convention are done by the caller. And so that's 1, 2, 3, and 11 caller here. And then the rest is done by the callee. So hopefully this looks somewhat familiar to lecture. So steps that are executed by the caller are 1, 2, 3, 11. And then steps executed by the callee are 4 through 10. And then we're asked what part of calling convention is considered the function prologue. So that's everything up until we execute, everything in the callee section up until we execute the function. So that's 4 through 6. And then function epilogue is everything after we execute the function, so 8 through 10. All right, so that's all of our calling convention stuff. And now last two segments. So what does no-op do? So no-op stands for no operation. And simply it moves the EIP up by 4 bytes. But the EIP doesn't, consume anything or anything similar to calling convention. It just moves it up. All right. Now lastly, we're given this segment of code, or this is a program stack, and basically I've edited the program so that when bar returns, which is this function, pop EIP will be popped into the EIP, which is then executed to pop the RIP of main into the EIP. So basically like some Evan-bot's trying to achieve a double return. But note that the value pop EIP on the stack represents the actual value, not a variable name, not a pointer. Is this correct? Why or why not? So this is not correct because EIP needs an address and pop EIP is a command. Instead, we could have provided the address of pop EIP to achieve this. We should have provided the address of pop EIP. So that's going to be somewhere in code. And if we had provided that, then the EIP would point to this pop EIP command. It would execute it, and then that would actually consume the RIP at main. So that's the end of question